Hello and welcome, ladies and gentlemen, to our third part of Packet 5, Activity 5.1. This will be the last part of this video. We just did 11C at the end of the last video, so we're just going to go ahead and start out on number 12 right here. It says, consider triangle ABC with vertices -7.5, 2, -5.5, 13, and 2.5, 2. And then it says, determine the perimeter of ABC, round your answer to the nearest hundredth if necessary. So for this problem, our triangle has 3 sides, so we're going to need to know the length of those 3 sides and then add them so that we can get our perimeter here. So the first side that I think is easiest to get the length on is this AC, or CA as I have it down here. Okay, so the way that we can do that is we can actually just count units because it's on a grid line. Now the one thing that we do need to pay attention to is that A is at this half unit, or this half square right here, so then when we count we need to go by halves. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then actually C is on a half unit as well. So CA is 10 squares long, and then we just need to check how big each of these units are. It looks like we go from 0 to 1 to 2 to 3 to 4. So each square is 1 unit, so 10 squares is in fact 10 units. So that's our length for side CA. For side AB now, we have to do some distance formula. So I'm going to have the square root, and then so side A, we're going to go like this. We're going to go x, so here we're going to go x1, x2, and can you see that? Yeah, x1, x2 right there, and then, or x1, y1, wow, it's early in the morning. Okay, here we go, and then x2, y2. Sweet, so when I plug these in, it's going to be -5.5 minus -7.5. Wow, it really is early. -7.5 plus, and then 13. Here we go, sorry. And there we go. So then both of those are squared. Okay, so this -5.5 minus -7.5, when we subtract a negative, it's like adding a positive. So this would be like -5.5 plus 7.5, which is we're just gonna go right over here. That would be like 2, and then we have to square it, plus 13 minus 1 is 12, that squared. Okay, so then that means we're gonna have the square root of 4 plus 121, which is the square root 125. And am I still on the screen? Good. Sometimes I gotta double check. And then the square root of 125 is 11.18. Okay, so that is side AB. So now we've got 2 of our sides, and then for BC I'm actually going to hop down here and do it just because that way I don't run into my AB calculations. So for BC, I'll go ahead and use x2, y2 the same here, and then I'll just go x1, y1 right there. So now we're doing line BC. So here we got a square root. So we got x2 minus x1, so -5.5 minus 2.5 squared plus, and now we have y2 minus y1, which is going to be 13 minus 2. Ooh, and I actually, did I do some bad math, it looks like? Oh yeah, sorry, I'm looking at my notes over here. So for AB, this should be 13 minus 2, because we have, we were doing y2 minus y1, so this should be 13 minus 2. And then over here we should have 11 instead of 12. And then I did have this right because I was looking at my notes. So 11 squared is 121. So 4 plus 121 is still square root of 125, and then 11.18. So this is the correct length. I just had some incorrect numbers in here, so just double check on that. Again, it's x2 minus x1, y2 minus y1. And I just copied down the wrong number. So there you go. And so now, sorry, back down to BC. Back down to BC, so here we go. Now we have, so -5 minus 2.5, that's going to be -8. Yes, -8. -8, and we have to square that, plus 11 squared. Again, 13 minus 2, this time I did it correct, and that's actually what made me double check this one up here. So that means we're going to have the square root of 64 plus 121, which is the square root of 185 which is equal to 13.6. And it's 0.60 because it did say we need to go to the hundredths, but you don't have to include that if it's a exact unit. Okay, so now we still need to calculate our perimeter. So we're down here. Perimeter is going to be equal to all three of our side lengths combined. And then I'm just going to go ahead and do this for some consistency here. There's our three sides circled now. So here we go. Now we have side CA, 10 plus 11.18. That was side AB plus 13.6. That was side CA. And when you add those all together, we should get 34.78. Okay. If you want to double check that on a calculator, you can. That's just what I had from my notes from earlier. So hopefully that's correct. If you catch an error on these, go ahead and let me know. Maybe some extra credit, because it means you're watching these, which is good. So that was 12 to determine the perimeter. So now 13 says consider how to determine the area of this triangle ABC. So I'm actually going to move this over for now. So consider how to determine it. So we know that for triangles, our area is 1/2 base times height, or I just wrote it like this: 1/2 times base times height. Again, I've said in the last couple of videos, there's a couple different ways you can see this. Area equals base times height, all divided by 2. And then you could also flip these 1/2 height times base. It's all the same because, again, with multiplication, we can flip those however we would like. So now, part A, 13A. What information is needed about triangle ABC to determine its area? So in order to determine the area, we're going to need a couple things. We're going to need a base and we're going to need a height. So we can just say we need a base value and height value. And again, if we have those two things, then we can just plug it into this equation right here and then get an area out. So that's why we need these two things. Okay, so now we're looking at part B right here. It says Arlo says that line AB can be used as the height. Trisha disagrees and says that line BC can be used as the height. Randy disagrees with both of them and says that none of the line segments currently on the triangle can be used as the height. Who is correct? Explain your reasoning. So again, we're looking at this triangle up here. So Arlo says that line AB is our height. So he's saying this one is our height. Okay, and then Trisha says that BC should be our height. And then finally, Randy says that both of you are wrong. We need to do something different. So what we need to think about here is which one of these lines truly represents the height of the triangle. Okay, so remember, if we have right triangles, so I'm just going to draw a little triangle down here. Say we have a right triangle. Okay, our base would be right here, right? And then our height is right there. And with right triangles, it's nice because our height goes, we can just count straight up. That's easy. But with a triangle like this, we can't just count straight up to get our height, which is why they're having this discussion, right? So Arlo says that this line would be the best for the height. Trisha says this one, and then Randy says neither. So actually, in fact, Randy is correct here. What we need to do is we need to calculate the height as the highest point away from the base. So if we're using AC, this line AC here is our base, the point farthest away from our base is actually point B. And so to calculate the height, or to know what the height is, we need to find the distance from B to our base. So, and we'll do some more of those calculations in a second, but for now, to answer question B, who's correct, we would say Randy, and then we can say because our height needs to be the height needs to be from our base directly to the farthest point from the base. And so if that's a little confusing for you, our height needs to be from, wow, this is a little confusing, but here we go. Randy, because our height needs to be from our base directly to the farthest point from the base. So basically what I'm saying is it needs to be from our base directly to the highest point from the base. And then we will get some restrictions on that, which we'll talk about in a second. Okay, so part C right here says draw and label line BD to represent the height of AC, then determine the height of ABC. So BD, it just wants us to put a point on the base and then draw our height BD. So one thing that is important to note here, that we'll talk about more as well later, is that our height is always going to be perpendicular to our base. So if our base is AC, then we need to draw a height line that is going to be perpendicular to that. Now it's nice that AC is a horizontal line, because as we talked about, vertical lines are always perpendicular to horizontal lines. So this means that I'm just going to draw some kind of vertical line that connects to B. So what that means is, if B is right here at this half unit, if I just drop a line straight down from there, or the better way to think about it would be drawing a line straight up from your base, then that is going to be our height. And you can see how this line represents the height of our triangle, right? Because if I were like over here on the side, and I did something like this, you can see that our triangle is that tall, right? And so I need to draw something to match this on our triangle. And so the way I do that is by drawing a line perpendicular to our base that connects with the point farthest from the base. So there's our line BD right there, okay? So now it says we need to determine the height of BD. So I'm just going to go ahead. So here we are. It says we need to determine the height of ABC. I'm just going to grab my extra sheet of paper right here. Okay, so determine the height of ABC. Here we are. And actually, we actually don't need to do any calculations. The way that we can do this, if we look at our triangle, okay, we said that on AC we could just count units because it's on a grid line. Same with line BD here. It is a vertical line, so even though it's not directly on a grid line, we can just count squares here. So from D, we go up 1, 2, 3, 4, 5.5. Go up 5.5 squares, and then we need to just check what each square is worth here on the y-axis, and it looks like we're going up by 2 each time. 2, 4, 6, 8. So that means that our height is going to be 11. And the reason that is because we had 5.5 squares times 2 units per square, and so we had 11 units. Okay, just so that we're all clear on that. So now we get to determine the area of triangle ABC. So we had that our base, we said that line AC or CA, as I had it labeled earlier, they're both the same, okay? We said that that was equal to 10, and then we just said that our height, and this was our base, okay, equal to our base, and then our height was 11, so that means that our area is going to be 1/2 times 10 times 11, which is going to be 5 times 11, which is equal to 55. Okay, so our area for this one is equal to 55. And then our height, again, over here was 11. So that was problem 13. Okay, now we're going to flip this over. Well, not flip this over, that's 11. Okay, so now we're going to be looking at 14. Here we go. So consider a more efficient way to determine the area and perimeter of triangle ABC. And then part A says transform ABC on the coordinate plane. Label the image A prime, B prime, C prime. Describe the transformations completed and explain your reasoning. So I want to transform this to make my job easier. We talked in the last video about how transformations that move us into the first quadrant are nice and easy for us. So I'm just going to go ahead and do that. So the way that I see to do this is I'm going to move A to my origin. So that means I need to move A over 1, 2, 3, 4, 5, 6, 7.5 units, because 7 took me to right here, so 7.5 units. So I'm going to want to go to the right 7.5, and then I want to move down 1 square, but 1 square on the y-axis is actually 2 units, so then I'm going to move it down 2. So what that's going to do for me is now I'm going to have my triangle with point A prime right there. So this is something that we need to be careful about. We said that line AC had a length of 10. And actually the better way to do this would be just to do all of those transformations with all of our points. 7.5 and then 2 down. So C, I would go 1, 2, 3, 4, 5, 6, 7, puts me right in the middle there, and then a half puts me on the end, and then down 2, which is 1 square, so that puts me right there. There's C prime. Okay, and then for B prime, I'm going to go over, so this one's right in the middle of a square, so I'm going to go over 1, 2, 3, 4, 5, 6, 7.5 puts me right there, and then down 2, which is just down 1 square, puts me right there. Okay, and I'm just going to connect these It would be best to connect these with a ruler if you have them. I don't have one on me currently, so I'm just going to draw those, and not too bad for no ruler there. But okay, so it says describe the transformations completed and explain your reasoning. So transformations, we did say it went over 7.5 down 2 units, and then for our reasoning, we could just say something about how we wanted it in the first quadrant. So we wanted A prime, B prime, C prime all in quadrant 1. Perfect, okay. So now we're looking at part B. It says determine the perimeter and area of this new triangle. Round your answer to the nearest hundredth if necessary. So we talked in the last video, we've talked in a couple of videos now about how translations, so slides, don't move us, or don't change the size of our shape. And so if I slide back up to my transformation, it doesn't change the size of our shape, it just changes the position, right? We just moved all of these dots, but it shouldn't change the length. Oh, and then this was B prime, just so that we have it labeled. So it shouldn't change the length from AB to A prime, B prime. And so because this is the third part of this video, and I have a couple problems left to go on 5.1, I'm just going to go ahead and say that our area is still going to be 55, and our perimeter is still going to be, what was it, 34.78? Yeah. 34.78. And the reason that these should be the same is because, again, translations don't affect size, they only affect position. So if you do these calculations and you get numbers different than these, you should double check your calculations, okay? Just because this is what you should be getting, or you should be getting the same thing as you got the first time, okay? So now it says part C, and part C actually goes on to talk about that. It says compare these calculations to your previous calculations. How did the translation change your calculations? So comparing them, they are the same. And how did the translation change your calculations? It didn't. And then also, it shouldn't. Translations shouldn't change our calculations, other than making it easier or harder. They shouldn't change like the actual number of values that we get out of those things. Okay. So here we go, and oh sweet, there you go, look at that. So that was the last part of activity 5.1. Only took 3 parts, so I will be coming at you guys with an activity 5.2 video soon. Stay posted, and I will see you guys all in class. Have a wonderful day, and I will talk to you soon.